Okay, Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. Okay, baru ada 4 orang. Okay, tolong bagi tahu kawan-kawan yang lain supaya masuk live ni ya. Sebelum kita mulakan kita punya presentation. Okey, kita tunggu sekejap kawan-kawan awak yang lain join. Okey, sebelum saya mulakan. Okey, bismillahirrahmanirrahim. Okey, selamat tengah hari. Okey, seperti yang saya dah plan lah. Okey, untuk kita buat presentation secara live, okey, and online. Okey, yang mana untuk this chapter saya tak ajar awak dah, cuma you akan dengar penerangan daripada kawan-kawan awak. Okey, dan you boleh jawab lah. Okey. Okay, very good Azim. Okay, panggil kawan-kawan lain. Okay, ada baru kat sini saya tengok ada baru 8 orang. Okay. So pada kumpulan yang pertama yang akan saya bagi urutan dulu ya. Siapa yang akan saya playkan, kumpulan mana yang saya akan playkan dulu ya. Okay, pertama kumpulan Syazwani 4.1 dan kumpulan Zatin 4.1. Okey, seterusnya kumpulan Anissa 4.2, kumpulan Nurul Syafiqah 4.2, Syafiq 4.3, Aida Sofia 4.3 and Syukriah last kira. Okey, so get ready lah untuk urutan ni. Okey. Okey, so boleh bagi tahu kawan-kawan yang lain. Okey, cepat masuk untuk kita present lah. Okey. Okey. Okey, baru 10 orang ni. Mana lagi yang lain ni? Okay, 8 orang watching. Yang lain mana? Okay. Okay, sekarang pukul 12.05 saya tak nak habis bagikan masa sebab you akan banyak group kelas awak ni. So saya akan mulakan dengan kumpulan Syazwani. Okay. Okay. Okay, kalau yang ada dalam ni boleh tengok kat slide. Okay, saya akan mulakan
This
sekarang.
is the subtopic for 4.1. Okay, aromatic compounds. So the objective of learning is, the first one is students should be able to describe the aromaticity. So what is the criteria for aromaticity? So the first one is cyclic. Second one is planar. Okay, most of the time cyclic it will always come together with planar. And the third criteria is completely conjugated. And the last one is obey the Huckel's rule. Okay, let's look how to identify the aromatic compounds. So sini ada benzene. Okay. So the definition is aromatic compounds is a cyclic conjugated molecule or ion that is stabilized by electron delocalization. Aromatic compound contains at least one benzene ring in its molecule. Structure criteria. Okay. First one, this is cyclic and it is planar. It is always come together. And it is completely conjugated. Why? Because example 1, benzene is aromatic because it is cyclic. And it is planar. Cyclic and planar always come together. It is completely conjugated. Why? Because we can move the paigon dekat the other side. So we can draw it like this. Like this. We can move the paigon at the other side. So we can draw like this. Sini, and then sini. So kita boleh draw dia dalam bentuk lain. 1, 2, 3. Ada 3 paigon. Each paigon contains 2 electron, and 2 electron. So 6 electron equal to 4n plus 2. So 6 tolak 2 equal to 4n. So 4 equal to 4n, n equal to 1. So dia OB. Sebab Huckel's rule kan, n dia equal to 0, 1, 2, 3 and more. So look at the example 2. Cyclobutadiene is not aromatic because, okay, kita tengok first. It is cyclic. It is planar. And it is completely conjugated. Tapi sebab apa saya kata dia completely conjugated? Sebab we can move the paigon dekat the other sides kan. Tapi dia tak obey the Huckel's rule because okay, sini ada 2 elektron, sini ada 2 elektron. So 2 elektron tambah 2 elektron equal to 4n plus 2. So 4 elektron tolak 2 equal to 4n. So 2 equal to 4n. So n equal to 1 over 2. So dia tak obey the Huckel's rule. Sebab Huckel's rule, n equal to 0, 1, 2, 3 and more. That's why we say that it is not aromatic. So cyclooctatetraene is not aromatic. Okay, because it is cyclic, it is planar, it is, okay, kita tengok dia completely conjugated or not. Okay, it is completely conjugated. Tapi okay, kita tengok dia obey or not Huckel's rule kan. Okay, kat sini ada 2 elektron, 2 elektron, 2 elektron and 2 elektron. So dia ada 8 elektron equal to 4n plus 2. 8 elektron tolak 2 equal to 4n. So 6 elektron equal to 4n. And then n equal to 3 over 2. So it is not obey. It is not obey. Because Huckel's rule is n equal to 0, 1, 2, 3 and more. Okay, let's look at the example for Naftalin aromatic. Why? Okay, it is cyclic, it is planar, and it is completely conjugate. Sebab we can move the pi-bond at the other sides, so the double bond is moved freely, and then it is obeys the Huckel's rule. Dia ada 1, 2, 3, 4, 5. So dia ada 10 electron equal to 4n plus 2. So 10 tolak 2 equal to 4n. So 8 equal to 4n. So n equal to 2. So it is obeys the Huckel's rule. So example 5, biphenyline is not aromatic because because it is cyclic, it is planar, it is completely conjugated, but it is not obey the Huckel's rule. It is disobey. Dia ada 1, 2, 3, 4, 5, 6. So 6 darab dengan 2 elektron. So dah ada 12 elektron equal to 4n plus 2. 12 tolak 2 equal to 4n. 10 equal to 4n. So n equal to 5 over 2. It is not obey the Huckel's rule. So we prepare 3 questions for you guys to answer. That's all from us. Thank you for watching.
Okay, thank you Syazwani and their group. Okay, ada soalan you nak share dekat sini? Syazwani, group awak ada soalan ke nak share? Boleh jawab kat komen ya. Kalau tak ada, saya akan proceed dengan okay. Okay, state the criteria of aromaticity. Okay, ada tak yang nak jawab? Boleh jawab. Actually waktu kawan awak present tu ya boleh tanya. Okay. Siapa yang nak jawab soalan Syazwani yang first ni? State the criteria of aromaticity. Okay, cyclic. Okay, ada soalan lain? Fatihah Anissa. Okay, jawab je terus kat komen. Terus jawab. Plana. Okay, cyclic plana lagi. Okay. Syazwani, Nosham. Okay. Okay, untuk next group seterusnya nanti, waktu kawan awak tengah present tu pun yang boleh dah come dengan soalan dah. Okay, tak perlu habis. Nanti siapa yang tahu tu dia akan jawab lah. Okay, very good. Okay, so saya saya proceed dengan kumpulan lain. Okay. Okay, ada soalan lagi. What is an aromatic compound? Siapa nak cuba? Okay, apa dia aromatic compound kawan awak tanya? Anyone nak try? Ada yang nak cuba? Okay, nanti group Fatih ni boleh respon ya. Pada kawan-kawan tu betul ke salah ke? Apa dia jawapan dia? Okay, ada yang nak cuba? Apa dia jawapan? Tak ada. Apa dia aromatic compound? Okay, Fatin boleh share jawapan. Apa dia? Apa jawapan untuk ni? Okay, sambil nak tunggu Fatin ni, saya proceedkan dengan kumpulan seterusnya. Okay, kumpulan Zatin. Zatin boleh prepare dengan you punya. Okay, jap. Okay, jap. Okay, kita mula kumpulan Fatin Fatin boleh. Okay, Zatin jawab aromatic compound is a cyclic conjugated molecule or ion that is stabilized. Okay, very good. Okay, very good. Okay, Zatin jawab. Okay, so saya proceed dengan kumpulan Zatin. You all boleh dengar dia punya presentation.
Assalamualaikum. Today we going to discuss chapter 4 aromatic compound, which is subtopic 4.1 introduction. We start with the learning outcome. At the end of this topic, students should be able to describe aromaticity and identify the aromatic compound. Okay, we proceed with the introduction of aromatic. Compounds are called aromatic because of their pleasant odor. Aromatic compound, also known as arenes. The word aromatic is referring to benzene and its structural relative. Aromatic compound is a cyclic conjugate molecule or ion that is stabilized by pi electron delocalization. Aromatic compound contain at least one benzene ring in its molecule. There are 4 structural criteria must be satisfied for a compound to be aromatic. First is cyclic. Your compound must be cyclic whether it have 4 carbon, 5 carbon or 6 carbon. Second is planar. The third one is completely conjugate. It completely conjugate when your pi electron must be able to move around freely. The fourth is obey Hacker rule. What is Hacker's rule? Okay, Hacker's rule state that a number of pi electron equal to 4n plus 2 when n equal to 0, 1, 2, 3, which is integer. So, what is pi electron? Pi electron is double bond in a compound. We look at the example 1. Okay, we look at the picture of the benzene. Okay, there are 3 double bond there. One double bond contain 2 electron, so that there are 6 electron contained in the benzene. We insert 6 pi electron into the formula, which is 6 pi electron equal to 4n plus 2. Then we need to find n. 6 minus 2 equal to 4, n equal to 4. So, n equal to 1. When n equal to 1, it is the integer. Therefore, benzene obeys Hacker rule. Benzene is aromatic because it is cyclic, it's planar, completely conjugate, and it obeys Hacker rule. Okay, second example is cyclobutadiene. Okay, look at the picture. There are 2 double bond there, so one double bond contains 2 electron, and it have 2 double bond, so the pi electron is 4. Then we insert 4 pi electron into the formula, so 4 pi electron equal to 4n plus 2. 4 minus 2 equal to 2, so 4n equal to 2. n equal to 1 over n equal to 1 over 2 is a fraction, so it not a integer. So the cyclobutadiene disobey the Hacker rule. and it's not aromatic. Example 3, which is Naftalin. There are 5 double bond, so one double bond contains 2 electrons. So that there are 10 pi electron contained in the Naftalin. So we insert 10 pi electron into the equation, which is 4 pi electron equal to 4n plus 2. So 10 minus 2 equal to 8. 4n equal to 8. So n equal to 2. When n equal to 2, it is integer. Therefore, Naftalin obeys the Hackett rule. Naftalin is aromatic because cyclic, it's planar, completely conjugate, and also obeys Hackett rule. Okay, example 4 is biphenyline. Okay, look at the picture. There are 6 double bond contained in that compound, so that the electron is 12. So we insert into the formula, which is 4n plus 2 equal to 12. 12 minus 2 equal to 10, so 4n equal to 10. N equal to 5 over 2. When n equal to 5 over 2, it is not an integer, so that biphenyline disobey Hackett rule. So biphenyline is not aromatic. That's all from me. Thank you. Assalamualaikum.
Okay. Okay, group Zatin dah present, very good. Okay, so dia pun dah tanya soalan. Okay, saya teruskan dengan kumpulan seterusnya. Okay. Saya teruskan dengan kumpulan seterusnya. Okey, seterusnya kumpulan Anissa kumpulan Anissa. Okey, Anissa prepare dengan soalan siap-siap nanti boleh tanya. Okey, so saya akan playkan video dia lah.
In this video, we would like to explain about topic 4.2, which is
Bulan
Benzene Derivative.
Anissa boleh standby dengan soalan.
Hi, my name is Naftalin Anissa binti Muhammad Bakri, and my second group members is Anis Faiza binti Syed Rusti, and my third group members is Putri Aisyah Adlin binti Fakaruddin. I will start this video by explaining about monosubstituted benzene. Mono means that we have only one substituent. Now, I will tell you how to name the benzene by IUPAC name. It says that benzene is the parent name and the substituent is indicated by the prefix. So, the first example is chlorobenzene, which means that we have the presence of Cl in our benzene. There is no number needed because it will definitely be number 1, because Cl will definitely sit at carbon number 1 because we only have one substituent. Okay, next we have bromobenzene due to the presence of Br in the benzene ring. Then we also have nitrobenzene because obviously there is the presence of NO2 in the benzene rings. And the last example, we have ethylbenzene due to the presence of ethyl in the benzene ring. Okay, next, we also have 6 special names of benzene that we need to know. What is it means by special name of benzene? It means that other than common IUPAC names, we can also use this special name to replace the common names, which means like it is the famous name of the benzene. Okay, the first example is methylbenzene, which its special name is toluene.
So, when we have CH3 directly bonded to carbon number 1 of our benzene, we can call it as toluene. Okay, then the next example is hydroxybenzene, which also known as phenol. Then the third one is Amino Benzene, which we can call as aniline due to the presence of NH2. Next, we have phenylethanol, means that we have the presence of ketone in the benzene ring, which we also call as acetophenol. The next example is phenylethanol, which also known as benzaldehyde, means that the benzene is added with aldehyde. Okay, and the last one, we have this benzene carboxylic acid as its IUPAC name, which means that the benzene is being plus with carboxylic acid. So my question is, what is the special name for this benzene? That's all for me. Now I will let my next group member to continue with the video.
Hi, my name is Anisha Dr. PhD, and my topic is disubstituent. Disubstituent is two same substituent, maksudnya yang sama lah. And relative position of substituent ni kita boleh bagi nama dia ortho, meta and para, or kita boleh pakai number. For example, kita ada 2 chlorine 1 and 2, so kita namakan dia 1,2-dichlorobenzene, or kita boleh panggil ortho-dichlorobenzene. Next, kita ada kedudukan dia 1,3 kan. So kalau selang satu, kita boleh panggil 1,3-dichlorobenzene, or boleh panggil meta-dichlorobenzene. Next, kalau ada selang 2 karbon 1, 2, 3, 4, so kita panggil 1,4-dichlorobenzene, or kita boleh panggil sebagai para-dichlorobenzene. Ingat, sebelah-sebelah ortho, selang satu meta, selang 2 para. Okay, now anak dia nitro, so selang satu 1, 2, 3, so nama dia 1,3-dinitrobenzene or meta-dinitrobenzene. Okay, yang ni sebelah-sebelah kan. Okay, so kita panggil dia ortho-dinitrobenzene. Okay, tu yang anak dia sama jenis, nampak kan? Chloro-chloro, yang ni nitro dengan nitro. So macam mana kalau anak dia tak sama jenis? If two different substituent present, salah satunya akan jadi nama parent, new parent name. Okay, anak tu akan jadi carbon number 1. And, okay, this is priority order of substituent. Okay, yang first COOH and second C double bond OH and C double bond CH3. Okay, kalau kita perasan, semua ni CH double bond O punya group. Okay, and then ada OH and H2 and R alkyl CH group, and then NO2 and X halogen. Okay, ni kita ada banyak lagi contoh-contoh ni. Yang first kali is COOH dengan NO2, so parent dia yang C double bond OH ni kan. And nama dia is benzoic acid. Okay, nama anak dia nitro, berada di position yang kedua, so nama dia orthonitrobenzoic acid. Next, kita ada NH2 and Cl. So yang paling utama sekali adalah NH2, so nama dia adalah aniline. Aniline ni apa? Aniline ni dia punya special name. Jadi nama lengkap dia adalah chloroaniline. Di position selang satu, so nama dia adalah meta-chloroaniline. Okay, next kita ada Br dengan CH3, so kita utamakan Br. So special name dia adalah toluene. Anak dia bromo, selang satu, so nama dia meta-bromotoluene. Tulis nombor pun boleh. Okay, yang last ni korang cuba buat sendiri, okay? So, that's all for this topic. I would like to pass the next topic to the last presenter.
I am Putra Adlin binti Fakhruddin. As last presenter, so today my subtopic is benzene as substitute. Okay, let's see. Take a note, when benzene become a substitute, we will call a penny. So let's see how benzene will be substitute. Okay. So kita ada dua. Kita start dari sini, okay? Okay. When it attached to a side chain with more than 6 carbon atau lebih besar dari benzene, kita tengok first example. This is your benzene with the presence of a long carbon chain. So, macam yang kita tahu, benzene dan carbon-carbon single bond having the same priority. So, kalau dua-dua ada priority, become as a parent. Okay. So, kita kira Dekat lonceng ni ada berapa karbon? Ada 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 carbon. Jadi nama parents dia adalah octane. Manakala valine ada 6 carbon dan duduk di karbon yang ketiga. So nama dia akan jadi 3-penyl octane. Next, kita akan pergi kat sini pula, bahagian ni pula. Okay, when it is attached to a side chain which contains a functional group. Okay, look, when we have the functional group of carbon over here, having higher purity than your benzene. Okay, maksudnya functional group lagi tinggi daripada benzene. So, your functional group will become parents. Okay, so kat sini kita ada 4 carbon that we call as putih. And then, penyl kita ada di karbon yang kedua. So, nama dia akan jadi 2-penyl 1-butyl. Okay, alright. Another example, as you can see, we have functional group and benzene. So, who will become as parents? Of course, that carbon will holding the OH. Okay, over here you present of your alcohol. We have 5 carbon. So the name will be pentanol. OH duduk kat karbon yang kedua, jadi 2-pentanol. Okay, tengok penyl pula duduk di karbon yang ketiga, jadi 3-penyl. Kalau gabung jadilah 3-penyl 2-pentanol. Okay, so you can cuba equation. Alright, good luck and bye.
Okey, ada soalan lain tak? Grup grup Anis ni. Ada soalan lain tak nak tanya kawan awak? Hello? Ada? Sorry. Hello? Ada soalan lain? Okey, kalau tak ada, saya proceed dengan grup seterusnya. Okey, very good presentation. Okey, kita teruskan next presentation dengan kumpulan. Okey, Anissa. Okey, Nurul Syafiqah. Okey, ada saya naikkan soalan ni. Okey, sambil-sambil saya nak share tu, boleh jawab dulu. If there's the presence of fluorine carbon number 1. Okey, anyone? Ada yang nak jawab? Okey, okey, jawab dulu. Siapa nak jawab soalan ni tadi, soalan Anis ni? Okey, Fatin Husna jawab fluorobenzene. Betul ke? Betul ke Anis? Fluorobenzene, betul? Okay, very good. Okay. Betul. Okay, congrats Fatin Husna. Just you faham lah apa yang kawan awak present. Okay, so kita teruskan dengan kumpulan Nurul Aina Syafiqah. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Today, I will present about benzene derivative. So, this is my group member. 4.2 Benzene Derivative. The objective is, at the end of the lesson, students should be able to draw the structure and name the benzene derivative according to the IUPAC nomenclature for A. Monosubstituted derivative and B. Disubstituted derivative.
And students should be able to draw and give example of benzene as substituent penyl. Mono-substituted benzene. Mono means one substituent. So, according to iPad name, benzene is the parent name and the substituent is indicated by a prefix. So, NO2 attached in carbon number 1 with a benzene ring, it can be the nitrobenzene. It goes same to ethylbenzene. Ethyl attached in carbon number 1 with a benzene ring, it can be ethylbenzene. Attached to carbon number 1 with a benzene ring, it can be the fluorobenzene, and so on to the chloro and bromo. Mono-substituted benzene. So this is the 6th special name that you should remember. The first example is when a CH3 attached in carbon number 1 with the benzene ring, the common name, it will be the methylbenzene, but the special name, it can be the toluenes. Next, when OH attached in carbon number 1 with the benzene ring, it can be the hydroxybenzene. It's a common name and it will be the phenol in the special name. Next, when NH2 attached in carbon number 1 in the benzene ring, it will be the amino benzene in the common name, but in the special name, it can be the aniline. Next, when COOH attached in carbon number 1 with a benzene ring, it can be benzene carboxylic acid. It's a common name, but the special name, it can be the benzoic acid. Next, when CH3C double bond O attached in carbon number 1 with a benzene ring, it can be penyl methanol. This is a common name, but the special name, it will be benzaldehyde. Last one, HC double bond O is attached in carbon number 1 with a benzene ring. It will be the 1-penyl ethanol. This is a common name, but the special name, it can be the acetonol. So, this is the 6th special name that you should remember. So, let's move on to the di-substituted benzene. Di here means two substituent. It have a two substituent, which is same substituent and different substituent. Okay. Let's look up at the same substituent. Same substituent is relative position of substituent are indicated by prefix ortho, meta, and para, O, M, and P, or by the use of number. The relative position on benzene ring, ortho O, 1-2 position, meta M, 1-3 position, para P, 1-4 position. So this formula you should remember, because this formula is really useful for the next part. So example of di-substituted benzene for same substituent. Okay, so the first example, we are in the carbon number 1 and the carbon number 2. It will be 1,2 dibromobenzene. So 1,2 here is orta. So symbol for orta is O. So it will be changed to O dibromobenzene. Same to this one. We are in the carbon number 1 and carbon number 3. So it will be 1,3 dibromobenzene. But 1,3 is meta. So the symbol of meta is M. So it will be changed to M dibromobenzene. And last one is we are in the carbon number 1 and carbon number 4. So it will be 1,4 dibromobenzene, but 1,4 is para. The symbol of para is P. So it will be P dibromobenzene. You should remember, this one should be, korang semua kena faham dan kena ingat, simbol ni kena sentiasa letak sebab P atau O atau M hanya untuk position, hanya untuk nombor sahaja. Jadi, simbol dash still kena letak. So this is the other example for disubstituted benzene for same substituents. You can look at here. So let's move on to the different substituents. When two or more substituents are present, substituent with higher priority will be chosen to be the parent name. Maknanya kat sini, apabila satu structure ada dua substituent yang berbeza, kita kena pilih higher priority substituent yang mempunyai higher priority untuk jadi parent name. Contohnya kat sini, in the carbon number 1, it has COOH, and the carbon number 2, it has it has NO2. So, in this part, we will choose NO2 will be the parent's name because NO2 is the higher priority than COOH. So, it should have 1,2-nitrobenzoic acid. So 1,2 is symbol for O, symbol for orta. 1,2 is orta and the symbol is O. So it will be the O-nitrobenzoic acid. And the second example is, in the carbon number 1, it has OH, and in the carbon number 3, it has Cl. So it will be 1,3, a typo here. It will be the chloro benzoic acid, and 1,3 is meta, and the symbol for meta is M. So it will be M chlorobenzoic acid because Cl is the higher priority than OH. So this is the formula for priority of substituent groups. You have to remember this part. You must remember this part. Because the formula is really useful when you answer the question after this. So, COOH, it will be the highest priority. And this part will be the lowest priority. So, let's move on to the next part. Benzene as substituent. Penyl group. The name of benzene as a substituent is penyl. Maknanya kat sini, bila benzene ni adalah substituent, dia akan berubah menjadi penyl, bukan lagi benzene. Contohnya, benzene ring is considered when it is attached to a side chain with a more than 6 carbon. Bila carbon kat sini, side chain kat sini lebih daripada 6 carbon, automatik benzene ring akan berubah menjadi penyl. Sebab benzene ring apabila side chain melebihi 6 carbon, benzene ring akan menjadi substituent. So dia akan berubah menjadi penyl. Jadi it will be 2 penyl heptane. Because 7 carbon is heptane. Okay. Benzene as substituent penyl group. The second example. Benzene ring is considered as substituent when it is attached to a side chain which contain a functional group. Maksudnya kat sini, bila dalam satu structure ada double bond, automatik benzene ring akan jadi substituent. Dan dia akan berubah menjadi penyl. So, kat sini dia akan jadi 1 penyl 2 butane. Kerana kat sini kita ada 4 carbon. kat sini kita ada 4 carbon. The last one is bila ada functional group macam tadi, bila ada functional group, ada OH kat sini, benzene ring akan terus menjadi substituent dan dia akan bertukar nama menjadi penyl. So, it will be 2-penyl ethanol. So, that's all for today. That's all for this part. So, this is the extra question that you should answer. So, I hope you guys understand with what I explained about this part, and thank you guys.
Okay, tanya ya, kumpulan Aina. Okay, very good presentation. Okay, ada soalan lagi ke? You nak tanya pada kawan? Ada? Kalau tak ada, saya teruskan pada kumpulan seterusnya. Okay. Okay, canggih-canggih lah you punya presentation ni. Beyond my expectation. Very good lah. Okay, sangat bagus. Okay, so saya akan teruskan dengan kumpulan Syafif untuk chapter 4.3. Okay, so saya harap kumpulan Syafif bersedia ya dengan you punya soalan. Okay, nanti terus terus share. Oh. Okay, so ready ya Syafif and your group members untuk sediakan soalan ya.
For the topic aromatic compound, we're going to learn the subtopic 4.3 chemical properties. The learning outcome for subtopic 4.3 is the student should be able to write the chemical equation for the reaction of benzene in halogenation, alkylation, acylation, and nitration. Allotrophic aromatic substitution. This is benzene. Benzene is very stable and cannot break the double bond and can only substitute the H atom. So H atom located here outside the benzene. So electron-rich species also known as nucleophile. So only electrophile can substitute. Jadikan semula aja. Lah. Halogenation is a replacement of one of hydrogen atom on the benzene ring by halogen Cl or Br. So this is benzene ring. Benzene ring react with halogen Cl2 or Br2 in the presence of Lewis acid at FeCl3 or FeBr3 to form aldehydes. Function of Lewis acid is to produce electrophile. If you look at this example, kalau tak ada Lewis acid ni, tak ada lah electrophile yang akan dihasilkan. So kita tengok B ni tidak akan menggantikan H di sini kalau tak ada Lewis acid. Tengok ni. Dia tidak akan digantikan. Okay. Ini untuk halogenation. Second one is nitration. Nitration is replacement of one of the hydrogen atoms on the benzene ring by a nitro group. Benzene reacts with concentrated nitric acid at 50 to 55 Celsius in the presence of concentrated sulfuric acid to form nitrobenzene. This is benzene. Dia akan bertindak balas dengan concentrated acid di sini dengan katalis sulfuric acid pada suhu 50 ke 55 Celsius untuk membentuk nitrobenzene tambah H2O. Memandangkan NO2 ini adalah NO2 ini yang
Okey, kenapa senyap? Hello? Memang tak dengar suara Syafiq boleh respon tak? Memang tak ada suara ke macam mana? Okey, Nukman ada bagi soalan. Okey, boleh jawab state the function of Lewis acid. Apa fungsi Lewis acid kat sini? What is the function of Lewis acid? Okey, siapa boleh jawab?
Okay, we continue our lesson today.
Oh, ada.
We go to the example of the Friedel-Crafts hydrogenation. First,
Okay.
here we have a
Is that correct?
benzene
Jawapan
chain
kawan awak
to
ni?
react with 2-chloropropane. Here, the bond between carbon and Cl will break, and in this equation we have AlCl3 as our catalyst. The electrophile replace the part of H, and the H from the benzene chain combine with Cl, and the product is named as isopropyl benzene. To the second example of the Friedel-Crafts alkylation, we have our benzene chain here, and the benzene chain will react with 2-chloro-2-methylpropane. A catalyst of this reaction is AlCl3. The chain between the carbon and Cl will break, and this is our electrophile. The electrophile will replace the part of H. This is our electrophile. The electrophile will replace the part of H, and the H from the benzene chain will combine with Cl, and we go to the chemical properties. First, we go to the halogenation. The reactant of the halogenation is Cl2 or Br2. The condition of the halogenation is Lewis acid, such as FeCl3 and FeBr3. Secondly, we go to the nitration. The reactant of nitration is H2SO4 and the concentration of HNO3. The condition of nitration is 15 to 55 degrees Celsius. The third is Friedel-Crafts alkylation. The reactant of Friedel-Crafts alkylation is haloalkene. S equal to Cl or Br. The condition of Friedel-Crafts alkylation is Lewis acid, such as AlCl3. Lastly, we go to the Friedel-Crafts acylation. The reactant of Friedel-Crafts acylation is acid chloride, O equal to C bond with RCl. The condition of Friedel-Crafts acylation is Lewis acid, such as AlCl. Untuk subtopik ni, kita ada 4 benda yang penting untuk kita take note lah untuk subtopik ini, iaitu first, reagent or condition. Second, catalyze. The third is product, and fourth.
Ini adalah 4 electrophilic substitution reaction, which is the first one is halogenation, nitration, Friedel-Crafts alkylation, and Friedel-Crafts acylation. So kita tengok untuk yang pertama adalah halogenation.
Okay, anyone? No observation. Okay, kawan awak dah respond. Okay. Okay. Okay, correct Okay, unchanged. No changes berlaku. Okay, so saya teruskan dengan presentation dengan group seterusnya. Okay. Okay, kita dah selesai group Syafiq. And next group is Aida Sofia. Okay, group Aida Sofia. Okay. Okay, okay, saya harap group Aida ni bersedia soalan nanti saya akan berikan di akhir rancangan, di akhir nanti. Okay. So kita listen to the Aida Sofia punya presentation.
My name is Aida Sofia, and today I want to present to all of you about topic 4.3, chemical properties of benzene in chapter 4, aromatic compounds. Learning outcome is, at the end of this topic, students should be able to write the chemical equation for the reaction of benzene in halogenation, alkylation, acylation, and nitration. 4.3 chemical properties of benzene. This is benzene, and the properties is it is very stable. Because of it is very stable, it cannot break the double bond. Because the double bond cannot break, it only can substitute the hydrogen atom. Jadi apabila dia bergabung dengan compound lain, dia hanya akan menggantikan hydrogen atom ini sahaja. Benzene juga adalah electron rich species, or we call it nucleophile, and because benzene is nucleophile, only electrophile can substitute the hydrogen atom. Electrophile ialah electron poor species, and only the electron poor species can find the electron rich species, iaitu benzene, untuk menggantikan hydrogen atom ini. So as the result, this benzene can only undergoes electrophilic aromatic substitution. Next is the chemical equation. Okay, in electrophilic aromatic substitution, we have 4. First is halogenation. The replacement one of hydrogen atom on the benzene ring by halogen Cl or Br. Second is nitration. Replacement of one hydrogen atom on the benzene ring by nitro group NO2. Next is Friedel-Crafts alkylation, which means transfer an alkyl group to benzene. And the last is Friedel-Crafts acylation, transfer an acyl group to benzene. Okay. Next, we look at the example of halogenation, the chemical equation for halogenation. This is benzene. Reacts with the halogen Br2 or Cl2, and dengan bantuan catalyze iaitu FeBr3 or ElCl3, Cl for Cl, Br for Br, and produce product Bromobenzene, and the byproduct is hydrogen bromine. Sama juga macam ni, chlorobenzene and hydrogen chloride. Macam mana boleh dapat produk ni? Senang je. Kita tengok dekat Br ni ada 2. Satu Br akan pergi menggantikan hydrogen bond ni dengan benzene, dan satu lagi akan bergabung dengan hidrogen ni dan membentuk hydrogen bromine. Dan bromine yang bergabung dengan benzene akan menjadi bromobenzene. Sama juga macam Cl ni, satu Cl akan pergi ke benzene untuk menggantikan bond dengan hidrogen, dan hidrogen akan bergabung dengan satu Cl lagi dan membentuk the byproduct, and the product juga akan menjadi the chlorobenzene. Kena ingat apabila dapat chemical equation ni, at last kena tulis the electrophile. The electrophile maksudnya electron poor species ataupun positive charge ion. Kita nak tahu electrophile dia, kita hanya ambil compound yang ion yang bergabung dengan benzene iaitu Cl dan juga Br, dan kita hanya tambahkan just positif sahaja untuk tulis ni. Okay. Catalyze ni juga penting untuk tulis je. Next is nitration. Nitration hanya ada satu equation saja. Sama juga macam tadi, the benzene reacts with the concentrate nitric acid, dan dengan bantuan catalyze iaitu concentrate H2SO4, dan in condition at temperature 50 degrees Celsius, dan produce nitrobenzene dan juga H2O. Okay. Daripada concentrate HNO3 ini, NO2 daripada HNO3 akan menggantikan H yang bond dengan benzene, dan H tadi yang terkeluar daripada bond benzene akan bergabung dengan oksigen yang satu lagi yang berlebihan, dan membentuk nitrogen benzene, iaitu benzene dengan NO2 dan juga H satu lagi dengan O, H2O. Dan electrophile sama juga macam tadi, ambil ion yang ada dekat benzene ring dan hanya tambah positif charge sahaja. Okay. Next is Friedel-Crafts alkylation. Okay, kita tengok benzene reacts with the alkyl halidase, iaitu ini. R ni adalah art group ataupun we call it carbon group, and X adalah halida, iaitu Br ataupun Cl. Okay. Antara CH3 dengan Br ni ada bond, dan kita boleh break dia. Yang ni bersama, kita break dia. Apa-apa carbon group yang bond dengan halogen kita break, dan carbon group ni akan menggantikan hidrogen dekat bond benzene dan membentuk methyl benzene. Yang ini juga akan membentuk cyclobutylbenzene, dan hidrogen yang terkeluar daripada bond benzene akan bergabung dengan halogen yang disingkirkan tadi dan membentuk HBr dan juga HCl. Dan juga dengan bantuan catalyst iaitu AlBr3 for Br and FeCl3 for Cl. And sama juga macam tadi, electrophile dia adalah CH3 positive and the cyclobutane positive. The last is Friedel-Crafts acylation. Okay, yang ni kita akan tengok dulu dengan carbon, iaitu benzene akan react with the acyl chloride. This is, kita tengok daripada carbon ni yang attach dengan yang bond dengan halogen, iaitu Cl. Jadi bond antara C dengan carbon dengan Cl akan break, sama macam tadi, dia akan break. And carbon yang bond dengan benda lain, dia akan bergabung menggantikan hidrogen ini, dan akan bergabung dengan benzene dan membentuk this product. Dan Cl akan bergabung dengan hidrogen yang terkeluar daripada bond benzene dan menjadi HCl, sama juga macam ni. Yang ni bond ni akan bergabung menggantikan hidrogen dan membentuk this product dengan bantuan catalyst. Yang ni wajib tulis. Dan this byproduct sama macam tadi, electrophile, kita hanya ambil this yang bergabung dengan benzene dan hanya tambah positive charge sahaja. Okay. Kesimpulannya, untuk chemical equation ni, untuk keempat-empat chemical equation ni, dia perlukan reagent ataupun condition macam temperature ataupun concentrate compound and catalyze product, dan juga electrophile, positive charge ion. Okay. The last is question. Okay, yang ni senang saja. Sama macam tadi, dia perlukan catalyze.
Okay, untuk question, okay, saya tambah satu lagi share screen Okay. Okay, access screen. Okay, jap.
Product.
Okay.
Okay, that's all from me.
Saya rasa okay.
I hope you understand what I present for this topic, and thank you for lending your ears.
Okay, jap Sekejap. Keluar tak paparan awak? Okay, ini question untuk group Aida. Okay, so you all boleh jawab lah. Question 1 tu apa jawapan dia? Apa dia punya tindak balas, nama tindak balas tu? Okay, boleh komen sekarang. Okay, apa jawapan dia? Okay, awak keluar tak kat slide awak? Sekejap ni. Keluar paparan ni, ada gambar ni tak?
Assalamualaikum. My name is Aida.
Okay, patut dah. Okay, saya sharekan. Okay, ini soalan untuk group dia. Okay, so apa reaction yang pertama tu? Apa nama dia? Okay. Okay, boleh jawab. Okay, dah nampak kan? Okay, untuk tindak balas yang pertama, apa nama reaction dia? Tindak balas apa tu? Okay, kejap. So, yang kedua, apa? Daripada apa yang Aida dah explain tadi, okay, you teka lah. You boleh guess lah. Untuk first equation tu, tindak balas apa nama dia? Nampak kan kat paparan saya punya, kat YouTube saya nampak? Apa jawapan dia? Ni. Okay, kita ada benzene react with haloalkane with the presence of FeCl3. So dia jadi apa ni? Apa nama tindak balas ni? Apa dia? Tak dapat. Okay, yang kedua tu apa? Kita ada apa? Okay, dah nampak. Okay, cuba boleh jawab lah. Apa dia? Mungkin lag sikit lah dengan awak kot. Sebabnya ni kan. Halogenation yang first. Okay, halogenation ke? Okay, Aida boleh respon ya. Betul ke tak jawapan kawan awak? Group Aida boleh respon kat komen. Okay, yang pertama tu apa? Yang kedua tu apa? Betul ke Aida? Halogenation. Question number 1. You all jawapan tu tulis lah. Untuk soalan nombor 1 ke 2 ke 3 ke. Okay, soalan nombor 1 apa jawapan dia? Okay, Azim jawab number 1 tu alkylation. Betul ke? Okay, yang kedua, group Aida boleh respon ya jawapan kawan awak. Okay, yang kedua tu apa? Yang kedua tu apa? Ini, tindak balas apa ni? Apa nama reaction ni? Kita ada Friedel-Crafts alkylation, Friedel-Crafts acylation, kita ada halogenation. So which one? What type of the reaction ni? Okay, jawapan Azim betul. Okay, yang nombor 2 pula. Apa dia? Apa dia? Question 2 tu. Okay, acylation. Dia kena jawab penuh Azim. Friedel Craft acylation. Right. Betul ke Nurin? Friedel Craft acylation. Betul ke? Okay, Natasha Ali apa jawab acylation? Okay, group Aida tolong respon. Betul. Okay, question yang number 3. Okay, anyone nak cuba? Acylation. Okay, yang number 3 tu. Apa dia? Okay, nombor 3 apa jawapan dia? Sama kan? Friedel Craft acylation, right? Okay, yang nombor 3 pun Friedel Craft acylation. Okay, so stop sharing. Okay, kita pergi kepada kumpulan last kali saya tak silap saya Okay, last kali. Okay, saya sharekan video kumpulan Syukria. Okay, so Syukria. Okay, very good idea. That's a good answer. Okay, tolong ready dengan soalan ya. Okay.
Assalamualaikum.
Okay, so saya tunggu you all ready dulu. Okay, very good. Kita pergi kepada last presentation. Okay. Okay, so saya harap you all ready lah.
Assalamualaikum warahmatullahi wabarakatuh. Today I will present chapter 4 Aromatic Compound, which is 4.3 chemical properties. At the end of the topic, students should be able to write the chemical equation for the reaction of benzene in halogenation, nitration, alkylation, and last but not least, acylation. Electrophile substitution reaction, the most characteristic reaction of benzene. A hydrogen atom from benzene ring is replaced by an electrophile. First one is halogenation. Halogenation is replacement of one of hydrogen atoms on the benzene ring by a halogen, Cr or Br. Benzene reacts with halogen Br2 or Cl2 in the presence of Lewis acid like FeCl3 or FeBr3 to form a real halide. Function of Lewis acid, which is FeCl3 or FeBr3, is to produce electrophile. Here is the example of halogenation. Benzene reacts with Br2 with the presence of FeBr3 to form an aryl halide. Next one is nitration. Nitration is a displacement of one of the hydrogen atoms on the benzene ring by a nitro group, NO2. Benzene reacts with concentration nitric acid at 50 degrees Celsius until 55 degrees Celsius in the presence of concentration sulfuric acid to form nitrobenzene. So here this is the example of nitration. Benzene reacts with nitric acid with the presence of sulfuric acid to form nitrobenzene. The third one is Friedel Craft alkylation. Friedel Craft alkylation refers to the replacement of an aromatic proton with an alkyl group. This is done through an electrophilic attack on the aromatic ring with the help of carbocation. The Friedel Craft alkylation correction is a method of generating alkyl benzene by using alkyl halide as reactant. Example 1 is the addition of a methyl group to a benzene ring. The electropile attack on the electron system of the benzene ring to form a non-aromatic carbocation. Example 2. Example of benzene react with 2-propane to produce isopropyl benzene. The last one is Friedel-Crafts alkylation. Alkylation is a transfer an acid group to benzene. Benzene react with acid chloride in the presence of Lewis acid catalyst AlCl3 to yield benzobenone. Here is the example of Friedel-Crafts alkylation. That's all. Thank you.
Okay. Saya rasa semua dah habis present and semua dah apa tu. Okay, ada soalan nombor 2. Okay, sebelum kita tamat. Okay, you can see saya dah highlightkan dekat you punya ni. Okay, apa dia tanya? Soalan tanya, kawan nak tanya, what is the most ideal temperature, okay, of nitric acid when carrying out the nitration acid? Okay, so anyone nak jawab? Soalan Azim? Okay. Berapa temperature yang sesuai kan? Okay. So, kat sini Arifah Akila kata 50 and Farhana Amira kata 50 to 54. Okay, Azim boleh respon jawapan kawan awak ni betul ke tak? Arif Syahid, jawapan dia kata 50-55. Okay, Natasha Alia pun sama. Okay, Syukurah punya group members boleh respon, betul ke jawapan? Okay. Okay, betul. Okay, semua betul lah. Okay, so tanya. Okay, sebelum kita kita stopkan kita punya live ni. Okay, bagi saya bagi conclusion lah sikit. Okay, saya buka video. Okay, so saya akan buat conclusion tentang you punya presentation hari ni. Okay, so saya sangat berpuas hati. Okay, Alhamdulillah. Okay, my objective memang achieve lah. Okay, yang mana saya nak you bercakap. Okay, purposely I want you to involve in the lesson. Okay, saya tak nak saya je yang bercakap, saya je yang mengajar. Because of kita punya PDP mesti ada two-way communication antara lecturer dengan student. So saya harap this type of activity help you daripada segi you nak faham content and help you to develop, okay, ataupun untuk you lebih yakin untuk bercakap dan berkomunikasi dengan saya especially lah. Okay, so at the same time, thank you. Tak payah nak puji lebih sangat Okay, so at the same time saya nak you faham content tentang benzene. Okay, so saya akan release soalan assignment pada hari Isnin minggu depan. Okay, dah tahu kan hari Sabtu ni kita tak jadi ganti. Okay, supposedly kita jumpa hari Sabtu lah, tapi kita akan jumpa pada hari Isnin minggu depan pukul 8 pagi tu kalau boleh face to face. Okay, kita buat face to face lah. Kalau tidak saya akan buat Google Meet macam biasa. Okay, so selepas tu you boleh proceed dengan tutorial. Okay, saya brief assignment tu sekejap je. Okay, you ada Sabtu Ahad ni you buat tutorial. Okay, habiskan tutorial chapter 4 and then kita akan discuss pada hari Isnin. Okay, itu yang pertama lah. Okay, yang kedua road to assignment and then you kena alert juga kita ada UPS, right? Okay, kita ada UPS pada week yang ke berapa tu saya tak ingat, tapi dalam 2-3 minggu lagi. So prepare and bagi saya tepukan untuk diri sendiri kerana you boleh present dengan baik. Okay, I'm very proud of you. Okay, so saya rasa itu saja kelas kita hari ini. Kita jumpa minggu hadapan dengan tutorial and kita punya briefing assignment. Okay, so saya akan publish soalan post test. Okay, semalam saya bagi pre test, post test untuk you jawab. Okay, saya bagi masa you hantar hari ni malam sebelum pukul 10 boleh? 10 malam saya letak attachment dekat GC, boleh tak? Boleh tak hantar sebelum pukul 10? Okay, boleh ya? Okay, so saya rasa itu saja. Okay, thank you class. Nanti saya bagi survey dengan ni lah. Okay, thank you. See you next week. Okay.